Hello children, welcome back to my channel. I am now dealing with 8th class maths, exploring geometric figures. In that, I should do symmetry. What is meant by symmetry? Some figures, when they are folded, each half coincides with each other along a line. They coincide with each other along a line. Coincide means exactly one upon another you can keep. Such figures are called symmetric figures, and the line which divides the figure exactly is called line of symmetry. So you can see here the figure, children. These two are looking 100% alike. If you keep it upon it, you will get it. One will exactly fix upon the other. So these two figures are formed by this line of symmetry. This line which is dividing it into exactly two halves. Then this is called as line of symmetry. So this line on either sides of the line you will be getting the same type of figures. Those figures are called symmetric figures and the line is called line of symmetry. Now, point symmetry. What is meant by point symmetry? A figure looks same when seen from upside or downside. That is from any two opposite sides. See this figure, children. From here, if you look, how is it looking? From down, if you look also, it is looking in the same way. That kind of figures are having point symmetry. That means, how do you know whether it is point symmetry or not? If you take a central point and through that, if it is rotated 180 degrees, means this top should come down like this. If you rotate it 180 degrees, if there is no change in the shape of the figure, then we will say that it is having a point symmetry. So we can check it by rotating the figure 180 degrees around a central point. See children, this is the one. When you rotate it like this 180 degrees, even then you will be getting the same figure. So it is called as point symmetry. The same thing you can see even here in these figures, parallelograms. Even in parallelograms, when you rotate it 180 degrees, you can see it. You can see it as it is. You don't have any kind of change in it. For example, if I take, we can. For example, children, if I take this figure, this is the center position, and if I rotate it 180 degrees like this, even then you are getting the same shape. It is not changed. At the center point, if you are rotating, the shape will not change. It is 180 degrees when you rotate it from the central point like this. 180 degrees if you rotate, the shape of this figure is not changing. This kind of ones are called figures which are having point symmetry. So some more examples of it we can discuss. What are the other examples of it? See, parallelogram, of course, such a type of figure I have shown. A star here also. Through this point, when you rotate it, you will be getting the same figure. See, because from top side, if you talk about this, from top side, if you look from top, from bottom, both of them are alike. So it is having line point symmetry. Similarly, these figures are also from top and bottom. If you see, it is looking like same figure. So when you rotate it 180 degrees, you don't get any change. In the same way, the English alphabets, in that letter X, you can rotate it. Even if you rotate, see from here and here, it looks like letter H, letter I, letter S, letter N, letter Z. These all, when you rotate it 180 degrees, you are getting the same figure. This kind of ones are called point symmetry. So line symmetry means they will look alike on either side. of the line of symmetry. Point symmetry means if they rotate 180 degrees around a central point, they look alike. They don't have any change. This kind of figures are called point symmetric figures. Note down, children. Now, tessellations. What are these tessellations? A pattern in which one or more geometric shapes that cover a flat surface completely without any gaps. These are called tessellations. This any geometric figures, see like even the various designs that are seen upon the uh, carpets, upon the floors also, upon the roofs, upon certain designs that are there upon the cloths. All these are called tessellations. So some examples, say I have drawn two types of tessellations. This is the one which has formed with the triangles, this with hexagons. So like this, certain geometric figures, they lie upon a flat surface without any gap between them. Those are all called as tessellations, children. Please note down. Now, 8.2 exercise, children. Cut bold type English alphabets and paste in your notebook. Draw possible number of lines of symmetry for each of the letters. Now, what I did, I have written A to Z English alphabets, and with the other colored pen, I have other colored marker, I have marked the lines of force. So this is the lines of symmetry, sorry. The lines of symmetry for A, for B, C, D, E, F you cannot do, G you cannot do, for H you have to, for I also you have to, J you don't get any lines of symmetry, K you have one, L also no lines of symmetry, M one, N also no lines of symmetry, O has got more number of lines of symmetry, P, Q, R, N, S. There are no lines of symmetry. T has got one, U has got one, V has one, W has one, and X has got one, two, three lines of symmetry. Y is having one, Z no lines of symmetry. So this is how first I have drawn the lines of symmetry. The first question is how many letters have no line of symmetry? What are they? See F, G, J, L, N, P, Q, R, S, Z. These are all the letters which don't have any line of symmetry. And how many letters have one line of symmetry? Say A, B, C, D, E, K, M, T, U, V, W, Y. These are the ones which have got single line of symmetry. And how many letters have two lines of symmetry? Two lines of symmetry, H is having, I is having. That's all. Next, how many letters have more than two lines of symmetry? See, O is having more than two, even X. Which of them have rotational symmetry? Rotational symmetry means when you rotate the letter, you should get the same letter after the complete rotation. What are we are having that B also when you rotate it totally from here, if you rotate it like this, again you will be getting the same B, C, D, H, I, O, X, and Z. These all are having rotational symmetry. When you rotate them, you will be getting the same figure after the rotation. Nice, same letter. Now the next one, which of them have got point symmetry? Means I have already explained you children. Point symmetry means at one point means the letters which if you look from top and bottom they look like alike. See H, I, N, O, X and Z. These all are having point symmetry. Please note it down, children. Now, second figure is second problem, draw the lines of symmetry for the following figures. Identify which of them have point symmetry Is there any relation between lines of symmetry and point symmetry? So these are the given figures, children. The black ones are given figures, and with the red line, what I have drawn all are symmetric lines of symmetry. And the question is what? Identify which of them have point symmetry. Actually, all of them are having point symmetry because the lines of forces are passing through a single point. They have point symmetry, and is there any relation between line symmetry and point symmetry? The relation is actually all the figures which are having line symmetry will definitely have point symmetry also. All those which are having line symmetry, they definitely will have point symmetry also. So that you should know, children. There are some figures which have only point symmetry but not line symmetry. But in case if the figures are having line symmetry, definitely they have point symmetry. So all the line symmetries will have point symmetry, but all point symmetries do not have line symmetry. Please note it down. Now third figure, children. Third question. Name some natural objects whose faces have at least one line of symmetry. Now we can take examples as moon, butterfly, sunflower, orange fruit, human face. These all are having at least one line of symmetry. More than one they are there. For moon, more than; for butterfly, one; for sunflower, more than one; here also more than one; human face, one. Now draw three tessellations, and then what you need to uh, find out the name the basic shapes that are used here. So I have drawn this one. It is a tessellation. It is a tessellation where basic shape is square. It is having basic shape as triangle, and this tessellation has basic shape as hexagon. It's not compulsory that you have to draw this, children. You can draw your own answer figures for this answer, children. Please note it down. So with this, I have completed this chapter. In the next class, I'll start with the new chapter.